Okay, before ending this topic, let me just give one example that can help you have more intuition about this process. Okay, so if x1 and x2 were all ones for a particular data item, and then yeah, and then y value will be assigned 1, right? And then e to the power of 1 will have maybe 2 point something, and then let's say it is 2.5. Okay, and then this 0 will be always converted into 1 here. And then what about this probability? It will be 2.5 and 1 and 2.5, right? So approximately, yeah, maybe 30%, sorry, 70%, right? And then what about this probability? It will be 30%, right? Okay, so in this competition between 1 and fixed enemy of 0, and this 1 will get assigned 70% probability. Okay, and now let's look at the effect of the bias, like this term. I'm going to use different color, like this one. Okay, so typically we start with the normalizing the input variable so that each of our input feature have a zero mean and the unit variance. Okay, so it's like roughly Gaussian distribution that has a zero mean and a unit variance or standard deviation, and also those coefficient values will be randomly initialized as maybe having a zero mean and some standard deviation like this. Okay, and then what about the expectation value of this part? So these two are zero mean and some variance, having some variance, right? And the x1 and x2 will also have zero mean, right? And then altogether, this one will have a zero mean, right, on average, right? And then, yeah, for x1 and x2, and then roughly this y value will have zero mean, right? So in terms of the competition between this 0, yeah, I mean against this 0, and then it will have roughly the 50% probability value, right? But what about the effect of this bias term? Okay, if this bias term was -4, okay, if it was -4, and then yeah, roughly this value will have the mean value of -4, which means we are giving, I mean, by default, we are giving a really low probability value to this guy, right? So we are imposing our kind of bias or kind of prior knowledge that the probability being this positive class is really low by default. Okay, so that's the effect of this bias. Okay, so again, if we do not know this x1 and x2 in advance, and then we can assume that on average this linear combination involving this x1 and x2 will have this zero mean, and thus roughly it will have the 50% probability value at the end, like this value, right? So if it was 1 and if it was 1, and then it will be the 50% probability, right? But yeah, in that case, our prior knowledge is saying that the probability for this positive class should be really low, so like -4 versus 0, which means this guy will get really low probability, like maybe 10% or even lower than that. Okay, so that's the effect of our bias, which is our kind of way of imposing our prior knowledge. But again, those three values of 3, 2, and -4 will be just fully optimized by our gradient descent algorithm, right? So we do not actually set set this bias value by our own. That is not the case, but this bias is actually learned by our algorithm. Okay, and also we can apply the similar kind of idea to this softmax classifier example as well. So yeah, among these three classes and their own linear combination coefficient learned as it is, as follows, and then roughly these parts, okay, these parts will have maybe zero means, okay, but yeah, our prior knowledge is saying that the first class will have much larger probability compared to the other two. And then this one is the second ranked in terms of our prior knowledge or the bias to have more probability. And then this guy will be the least, the class that has the least probability. Okay, so that's the effect of this bias term. And again, these bias terms will be automatically trained. And thus, for example, if y1, yeah, so if it was cat and if it was dog, and then maybe if it was sheep, and then if our training data had maybe 80%, no, it's too large. So 70% of the cat, and then maybe 20% of the dog, and 10% of sheep, and then those bias or class imbalancedness lying in our data will be reflected into these bias terms in this manner.